Good morning to one and all. Welcome to the eighth discussion on the series Student Scientist Interaction Program organized by the B.V. Jagadeesh Science Center. Today we have with us Dr. Sriraghavan, an eminent scientist, an independent researcher in astronomy and astrophysics. And also we have Director of B.V. Jagadeesh Science Center, Professor K.S. Nataraj, Principal of the National Degree College, Dr. Y.C. Kamala, the Vice Principal of the National PU College, Professor Mamata, and Professor Altaf, the Science Officer. Welcome you all to this program, one and all. And I extend a hearty welcome to all the students of the PG Mathematics and Physics students. Student Scientist Interaction Program is organized on the third Saturday of every month. And the objective of this program is to enable students to know what's happening in the science and technology, the recent developments and trends in the science and technology, and to enable them to interact with the scientists who are involved in the research to bring the whatever the developments in the field of the laboratory to the students so that they can pursue a career in the science. They can take up the profession in the field of science. As I've already mentioned, today the speaker is an eminent speaker, Dr. Sriraghavan, is the co-founder and president academics at Nagar. He is an independent researcher in astronomy and astrophysics. He is a passionate teacher in the areas of problem solving, science and mathematics with the expertise in educational design and designing learning programs and protocols. His contributions include leading the setup of Cambridge Global School in Patiala, 5C methodology, MSKT approach to training and mastermind skill development program for the 10th and 12th grades. Most importantly, he is an alumnus of our college, and during the academic year 94 to 99, I think, was the student year. And he is currently on the Board of Studies of Physics Department at National College, Jayanagar. Welcome to the program, sir. And now I request Dr. Sriraghavan, sir, to take over.
Thank you. A small correction. Doctor was used when I was doing my PhD and I didn't complete it. So a lot of people got used to that because PhD marks and I doctor anta. So they've kind of does not have it. There are a lot of people who put a lot of effort to do that. For some reason I am not convinced that it's required. I'll not take you in that direction because I know some of you have the dreams of doing a PhD. You should. Okay. So can we move the projection? Yeah, thank you. Becca, do you guys need the recording? Oh, recording is on. Okay. Getting me on record, that's the difficulty. So, first of all, thanks to Professor Nataraj sir. He's been my mentor, my guide for a very long time, from the time I started my pre-university in the college. I still remember I first went to the physics department and then I said I was interested in astronomy and astrophysics. And he connected me to the planetarium course at that point in time when Dr. Shailaja was running the program. Like any PU student, I was attending a couple of them and then I was missing a couple of them, okay? Depending on the convenience and the interest in the lecture, right? So some things were very interesting, some things were not. Sometimes the mathematics used to go right above the head. I was not prepared for it at that time. So then I had Professor Nataraj actually stand there, right there in front of the auditorium. I still remember the day. And like, Yako hogta ilvante neenu? Right? Because, see, the reason why I'm telling you all this is, when you have the right kind of people, the right kind of support, the right kind of environment, whatever you want to do, it will keep you focused on that. Okay, today if I am here doing what I'm doing, it's because of my teachers. Okay? Definitely parents give birth to us, they make sure that everything is comfortable for us, but your journey, they may never understand. In my case, they have never understood, even today. I'm telling you that because in your case, in some of your cases, it is going to be true. If you choose a path that nobody else has chosen, remember this, you're alone. Number one. So you have to wake up every day, whether you like it or not, go there and do it. Number two, there are people who will support you. In that sense, you're not alone. Never feel lonely. Okay? Oh, we have taken maths, we have taken physics, what's going to happen to us? Don't worry about all that. 1 million years ago, human species didn't exist. 1 million years later, the human species won't exist on this planet. It doesn't matter to the universe. Okay? But what matters is, we are alive today, and we are understanding the universe in a way that our ancestors could never understand. But of course, like what Isaac Newton said, I am able to see ahead, standing on the shoulders of the giants. Which means all the theorems that you're learning, all the mathematical formulations that you're learning, is something that was done few centuries ago by some of the brightest minds of that time to give you the edge to start from here. You have to use it, you have to start moving forward, and you have to understand the universe better, leave behind your mark in terms of the work that you do. To the universe, it just doesn't matter, but to mankind, it does. The mankind progresses. Today, wherever we are in terms of technology, wherever we are in terms of science, wherever we are in terms of humanities, wherever we are in terms of arts, we are here because somebody started something a century ago, a millennium ago, or probably 5,000 years ago. And we are continuing the tradition. And evolution is all about passing that information on. Your role, my role here, is to gain that information, process it, add our understanding to it, and then pass it on to the next generation. So I'm going to do that to you for the next maybe 1.5 hours about what I have understood with my efforts and with the efforts of my teachers who've struggled really hard to put something up in here. Okay? Because it's not easy when you're a teenager to accept everything and sit in a classroom confined by 4 walls and then try and understand. That's what reminds me of Eddington. So Eddington once said, if your mathematics, if all the foundations of mathematics is right, that you have understood correctly, then you should be able to go sit on Venus and come up with the theory of everything, and then come outside Venus and apply it, and it should work. What he meant was, the language of science is mathematics, and if you've mastered it, you don't really need to have a physical model. It will anyway work. And the proof for that was given by our own S. Chandrasekhar when he worked out the mathematics of what's happening at the center of a star. He didn't go into the center of the star to make some collections. Those days, neutrinos were not even detected. He came up with the theory of the white dwarf while traveling from India to the US, middle of nowhere. And those days, there were no big books on quantum mechanics. And he was 19 years old. I'm telling you this because there are some of you here who have that potential to do. Then you can counter me with the question, sir, what happened to your potential? I am doing what I can do. I know what are my limitations. I know how much I can understand. And I'm trying my best to further my knowledge. So in the process, I've built a good team with whom I can actually have a conversation, a team that can tell me when I'm right, when I'm wrong, a team that can challenge me. Because of all of that, I was able to come here and share what I have discussed with my team today with all of you, all right? So the basic idea, the universe, okay, how do we switch to this? Yeah, thanks. Somewhere during the journey, I realized that what if the universe was conscious of itself? What if the universe felt it was lonely? What if evolution was a trigger because universe felt that it was lonely? Just imagine 100 billion galaxies, 100 billion stars, and over 100 billion planets. All of them there, no life. Absolutely no life. What is the universe doing there? There's nobody to study the moon. There's nobody to enjoy the moonlight. There's nobody to enjoy the understanding that the moon's rotation, okay, and its revolution has synced up somehow. It's just happening there. Everything is going according to the plan, but no one to appreciate that. Imagine the universe a billion years ago, or let's go back 5 billion years ago. Sun was not there. The planetary systems were not there. The galaxies were there. The universe was there. It was expanding, but nobody cared. And today, with just around a million years of evolution, there is a creature on a planet Earth sitting in the NCJ auditorium thinking about the universe. Now, if you connect the dots, does it make sense that the universe actually led to evolution because it wanted somebody to see the beauty? It was thinking, but not the way you and I think. That is why the title, it was actually thinking in terms of certain calculations. It was creating certain situations which could lead to certain changes. And that change, what led to where we are today. If you look back 10,000 years ago, we did not understand the universe. We didn't even understand each other. Forget about universe. Universe was a very far off place at that time. But today, we have understood so many things. I'm going to take you through some fun journey and then some serious questions at the end. Okay? So how do I do something like this? Will it change? How does it work?
You have to say it and he'll change it.
Where is he sitting? Sitting there? Okay. So now I need to deduce what to do. I have to determine how to say it, and then I need to detect the guy who can do it for me. Good. Yeah. Is there a way I can move the slide? You should make it voice activated. Aita? Yeah. And ಇದು right to left ಯಾವ ಕಡೆಪ್ಪ ಇದು ಇದಾ ಹೋಗಲಿಲ್ಲ ಹಾಂ ಥ್ಯಾಂಕ್ ಯು ಕೆಳಗಡೆ ನೆಕ್ಸ್ಟ್ ಮೇಲ್ಗಡೆ ಆದರೆ ವಾಪಸ್ಸಾ ಥ್ಯಾಂಕ್ ಯು ಸೊ ಟುಡೇ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು take you through this journey through those three words, right? Maths, 3D, basically. In physics, those are the 3Ds that I thought we can discuss today, okay? The first part of to deduce, to determine, to detect, these things you've done it in 12th. Less than that, even nowadays I think people do it even in 8th grade. See, something that people never worry about this or never wonder about this is, in this equation, there's no mass of the satellite. You know what it means? You can throw anything into space. That's what it means. It doesn't depend. You can throw the rat, you can throw the elephant, they'll all go with the same velocity. That's the beauty, because of which, see there, they've built such a wonderful thing there. An international space station, size of a football, floating in air. Football field, sorry, size of a football field, yeah. Size of a football field floating in space. Of course, that will be decommissioned very soon, which means that now that will become part of the space junk. That's another problem that you guys have to worry about. Because when you're walking, a bolt or something like that can fall on you from space. You know, those things can happen. See, our generation created all the junk. Your generation has to clean it up. Okay? No, you need to accept that. It's very important. We have to work together. Okay? We created the pollution, you fight for the environment. Okay? But also remember, we created the mobile phone, you're using it. So, it's a give and take. We need to do that. We developed the internet, you're using it. Today you're born. So most of you were born in the era where internet was like a default mechanism. Internet in the next few generations is going to be like oxygen. People will simply believe that oxygen existed on Earth forever, without realizing that there has been a process of evolution. Okay? But you need to understand, if you are using what we gave you, then you should also be ready to clean up whatever we leave behind. Okay? So don't come back and compare like one of those kids on TV I see, you're polluting the universe, you have to clean it up. No. We have done our job, we have polluted it correctly. We've got you where you are. We've also told you that yes, we have polluted, there is a problem. Please find the solution. Now don't depend on us for everything. Okay? That's the rule between the seniors and the juniors. Okay? Now I'm talking like an NCJ senior and an NCJ junior to you. All right? And right now we are 3 generations sitting together. Okay? You, me, and my teacher, all in one forum. All right? So this is one of the things. This is the beauty. Once you understand the maths of how things work, how things are governed in space, all they had to do was just look up in the sky and figure out. That's what Newton did. He just looked up at the moon and asked one simple question: why isn't the moon falling to the earth? And he came up with the answer that it is falling to the earth, it's not finding the earth. Right? It's like if I throw this, it's going to find the earth. But if I throw it in space, it might never find the earth. The question is, what speed should I throw it so that it will never find the earth? But to answer that question, you need to have very strong basics of mathematics, a mathematical bent of mind. See, if we say that, for the sake of saying, I can say that if physics is the king of all subjects, mathematics is the queen. Without them, there's no kingdom. Okay? Some of you may come back and say, sir, we live in a democratic era, we don't care about kings and queens. Then you don't fit this discussion. Very simple. Go find something else, do something else outside. Yeah? But you've taken math, deal with it. Next. Good. So what we did was we figured out how the moon is going around the sun, going around the earth, and then we could also put things around it. Now we are looking at how we can travel from one place to another. Not just that, if you can see the bottommost portion there, can anybody take a wild guess what that is? That's a moon? Okay. Where do you think the photo was taken from? Give it a shot. There are so many things that you have read in the newspaper. Give me one answer where the photo could have been taken from. From some satellite. Yeah? Very good. But this was taken from some cricket stadium. Somebody just focused using their camera, 700 lens, and then took a shot. That's the power of technology today. You don't really need to go to space. Okay? Sitting on the earth with some of the best equipments, you can take some of the most revealing photographs. When I mean revealing photographs, not of people, I'm talking about space. Okay? Nowadays, anything we say can be chopped, can be trimmed, can be put in any other place, and then suddenly there's TV9 behind you. Yeah? Next. Very good. So, how the power of mathematics changed the way the human system evolved also depends on the moon. The reason why we call it lunatics is because of that. Okay, I will tell you why, all right? Now, what you see on the right side, most of you have seen it in the textbook, right? That's the reason why you have a calendar. That's the reason why you have 7 days in a week. Not the weekends, 7 days in a week. The weekend came up only after 2005. Before that, we enjoyed life every day. We didn't have to wait for Saturday, Sundays to take a break, take a vacation. Those things were not there before 1995, okay? So this particular thing that you see there is just the moon going around the Earth, all right? And the beautiful thing here is that the moon and the Earth do not go around each other in the same plane. Like the Earth is going around the sun in a plane, the moon is not going around the Earth in the same plane. For some reason, during the formation of that particular system, it was tilted by 5 degrees. See the beauty of geometry here. That 5-degree tilt avoided eclipse happening every 15 days. Just a 5-degree tilt. Otherwise, I mean, I would have loved it there because Bengaluru roads would be empty every 15 days. Isn't it? I mean, whenever there's an eclipse, you don't want to come outside. Fear. That's what I'm talking about, confusion. The confusion there is because people do not understand the simple mathematics that it's just the orbital planes that have just tilted by 5 degrees. And see the beauty of the universe here. What was it thinking when it did this? The answer to that is it wasn't. It was not planning anything for you. It just happened. And that's what you study in mathematics and also in physics as probability. It's just probability that something like this could have happened. And there's a chance that something like this could have again happened in some other star, in some other planet, with some other moon. And it's not zero. The probability of something happening like this, repeating something like this, is not zero. The best part is, even if the probability is 0.000000000000001, you will still detect a million of them like this. That's the power of numbers. Okay? So one, it was basic circular motion, but of course they don't go in circles, we know that, they go in ellipse. Okay? So you need to kick the circle a little, make it into an ellipse. It's easier that way. We are never happy with one. So single focus is not important. Split the focus, make the orbit into an ellipse, so you have 2 foci, right? And then operate with that. Then the calendar came out because we were tracking the moon. That was the easiest clock that we could have in the sky. Every day look up at the sky, moon. Okay, its phases are changing, so this is Monday, this is Tuesday, this is Wednesday. You could do that. Or you could just call it Ekadashi, Dwadashi, Trayodashi. Okay, and practice whatever you want to. That's the confusion. Okay? Why people do it on an Ekadashi? There is no rule like that. You could do it on a Dwadashi and eat on a Trayodashi. It doesn't really matter. But there is some kind of practice people have got into and they've stuck to it. Today, if you go, they will defend it with their honor and life. Honestly, they will kill you if you ask them why you are fasting on Ekadashi. Okay? And I keep telling people, whenever you feel stomach upset, you fast. It's important that way. I do. I don't look for Ekadashi, Dwadashi. Because I know it's just a matter of the position. If you call this the new moon, that the full moon, nothing is going to change. Because what you call full moon is actually half a moon. The other half you have never seen. You know, that's how crazy people are. Full moon. I don't think Indians ever called it full moon. Because I'm sure they realize that what I'm seeing is only one side of the moon. It cannot be full. Okay? So that's the lunatic stuff there. And we have only seen this side of the moon. We have never seen that side of the moon. China is actually planning to establish an entire colony there and start selling real estate so that nobody can see on the dark side. Brilliant, isn't it? See, we have such a powerful way of launching rockets to the Mars at the auto fair. But we don't have the intelligence of going there first and owning some real estate. Somebody who's doing it very expensively has already gone there, has set up something there, has sent a rover to find the soil samples, which they didn't have to do. India already has all the data about the lunar surface. Chandrayaan-1, though that worked for a very short time, did miraculous work, collected all the data, sent everything to people. All you need to do is sit and do the analysis. But there are no people to sit and do the analysis. The reason why we don't have people to sit and do analysis is it requires a brain to do it. And I'll leave it at that. This is just like that for you to engage. You can, if you want to determine the volume of an asteroid. I am sure each one of you sitting in this room can do it. Yes or no? You've learned how to find volumes of 3D objects, isn't it? How are you going to do it? How will you find the volume of this asteroid? What does it look like? I've already written there. I mean, you don't need to worry about it. Does it look like a shoe? Have you ever determined the volume of your shoe? You haven't done that, right? Go home and do it. It's fun. Really fun. You will understand how much you have never understood in the textbook. All that cylinders, spheres, and all that your volume that you've calculated, they're all ideal conditions. This is real. The real condition is, it's always absurd. The objects don't look symmetric. Okay? They're always closer to the truth. That is how it is. They're closer to a sphere. They're closer to a cylinder. The reason why we teach you those things in the textbook is it's easy for the teacher to teach. It's very easy to simply say area of the circle is pi r square. Nowhere they teach you how to calculate and estimate the value of pi. They will still tell you pi is basically circumference by diameter, the ratio of circumference to diameter. If that is the case, then I can write it in the form p by q, q not equal to 0, which is the definition of a rational number. And still you believe that pi is irrational. All mathematics students, you have to go back today and question that. If I can say pi is circumference to diameter, circumference is a number I can measure, it is going to be a real number. Diameter is a real number that I can measure. I can write it in the form of p by q, because c by d is basically p by q, and q is not 0 because diameter is not going to be 0 if it's a circle. It fits all the definition of a rational number. Yet, why do you call pi as irrational? And remember, pi has been irrational from the time universe thought about pi. Till the time you discovered pi in the microwave oven. It's still there, right? Next. The next thing about human species is our love for information. Okay, this generation has actually overdone it because they accept everything on the YouTube, everything on the internet is true. Okay, they have arguments about the YouTube video and say that, oh, it's shown on YouTube, it must be working. So my only warning to all of you is that please use your common sense before you confirm anything. And I also know common sense is not that common, but I am sure since you've come up to MSc, you must have some part of it remaining. Okay? So please use it whenever there is any content on your WhatsApp University, okay, or on your Facebook, Twitter, Instagram, anything that people post, which is not curated, which is not peer-reviewed. Please don't accept that. It's not scientific. And whenever you're searching for a content for your projects, please check the website. What does it end with? Is it .com, .edu, .in? Because each one has a different purpose. .com is simply there to make you a fool. It will sell anything on it. .in may or may not review it. Okay? Sorry, not .in. .in may or may not review it. .edu definitely reviews its content. The content is not put up on the internet just like that. somebody will review it, somebody will read it. There is an editorial team that will make sure that everything, information given is authentic. So whenever you're searching anything for your projects, please make sure you search only from EDU, put it up there, get it reviewed by your own people. I'm sure most of science is just common sense. If it doesn't fit into your common sense, you can always question that. Okay, so that's the most important thing. But what we did in astronomy is something much more. We actually discovered multiple ways in which we can look at the universe. Because Michael Faraday and others told us that there's an entire electromagnetic series that you can look at the universe through, not just through the two eyes that are sensitive to visible light. You need to build antennas, you need to build technology which can look at different wavelengths. So when we did that, we understood the universe in a completely different way. 1905, around sometime around that, 1900 to 1905, there was a new branch of science that emerged, which is very popular as quantum mechanics. Okay? Once the quantum world became open, became available for people to think, dive deeper into it, the whole universe changed. Not the way Avengers portrays that as the quantum realm. There's no such thing as a quantum realm in physics. We don't talk about it. But it's actually, in terms of the idea, it means how deeper and how smaller can you go into the atom. The deeper you go into the atom, the more confusing it is. Just imagine, who wants to come down in life? Do you want to come down once you've gone to a higher position? Would you want to do that? Like, you know, from a teacher, I know her from the day she was a physics teacher in the department to a vice principal today. We all like that growth, isn't it? Electron seems to have a different behavior altogether. It appreciates that only for 10 to the minus 8 seconds. Gets excited, goes there, and just simply makes a transition and comes back and says, I want to be here. It's grounded. Only few human beings actually do that. Either they are in the Himalayas or they are gone. They're not available in around Bangalore ashrams. Don't find them there. You will not find them there. The people who can really understand what it is to be excited and de-excited at the same time. Okay? There is a lot of physics behind all of that. You can actually do some research on that. Today, there are people who are working on it called quantum consciousness. What it means in simple terms is, does the electron know that it's actually not in its place? It's there in an excited place, it has to come down. So you can actually do some research on that. Okay? And you don't need to do physics for it. A lot of mathematicians can work on that. All right? So what did we do with all the information we have? We built more. We learned more. And what we realized is somewhere universe seems to appreciate 2D, 3D, you know, in terms of circles and ellipses, or spheres. It just loves spheres. Can anybody tell me why sphere is the best structure to operate when things are on their own? Why should nature choose spherical symmetry? I'm sure in your class somebody has told you that everything in the world left alone will simply come back and take that shape. Okay? So go home and read about Fermat's theorem. Okay? I'm not going to give you answers. Like I was telling Altaf sir that I stopped teaching a long time ago. Now I only confuse people so that they can go home and check the books, like, did we study this correctly? Because when you make the attempt to learn, you will learn it for your lifetime. When I tell you the answer, you will forget it by the time you walk out of the door. It's always good to find your answers. It's okay if you are not Isaac Newton. You will find Newton's laws on your own. When somebody slaps you, somebody pushes you, or you fall because you did not realize that there is no floor there, that's how you realize Newton's laws. The textbook is only telling you that these are the equations in which you can understand them. But life teaches you Newton's laws, day in and day out. Right? That is why we always say that for any acceleration, for your life to change, for your life to accelerate, the force cannot be internal. It's not your parents. It has to be an unbalanced force like your teachers, who can kick you from backside, from the outside, to create the exact acceleration in the direction that it requires. That's Newton's first law. You will not prepare for the exam no matter how much your parents shout at you. You will only prepare for the exam because your teachers are sitting on your neck to get it done. If you've understood Newton's laws in that way, you will never go wrong with Newton's laws. Next, what we did here, we looked at multiple things. So we went to Mercury. Why did we go to Mercury? What's the fun in going to Mercury? Take a wild guess. It's okay. You don't need to sit quiet. Take a wild guess. Why do we need to go to Mercury? Correct. It behaves differently than any other planet. See, people don't want to be crazy, but they love crazy people. Nobody wants to be called crazy, but they all like crazy people. That's why they call people like me on the stage. Otherwise, everybody else would be here, isn't it? You will always look for someone who is slightly off. That is why we always love Mercury, because it's slightly off compared to all other planets that we know. So going there and studying, that is what made Einstein and Eddington very famous. If you guys are into watching Hotstar, Netflix, and all those kind of stuff, there is a series, or there's probably a small documentary on Einstein versus Eddington. You should watch that. It's an amazing idea of human conflict between their love for science and their love for country. Okay? So there is Eddington, who is an English scientist, who is trying to understand gravity and all that, and there is the German, of course, he was Jew, but still German at that time, Einstein, who was already given a theory about relativity. And he had already told that if my relativistic understanding of all the gravitation is right, then Mercury should be showing some kind of change in the orbital behavior, and the star light should be bending around sun. So Eddington was hell-bent on testing that. But the whole of England was against Eddington, saying that you are trying to verify the theory of a German against whom we are fighting the World War. You will not enjoy those things because you live in a country that's already free. You don't understand the value of freedom. Not that even I was born in the country that was not free, but at least I love history. The history of science and how scientific ideas evolved. If you can understand and appreciate that, you will see the struggle that was going on in Eddington's mind. He was trying to verify and prove a German right when the whole country was against Germans. Imagine if you were in that situation, what you would have done. And Eddington stood by science. He said, look, I am going to do this experiment for the sake of science, no matter the whole world is fighting against Germans. And the story also says that Eddington's best friend was killed in the war by the Germans. And imagine, as a human being, he must be having so much against them. Your friend is being killed by a country that you hate, and you're trying to prove the theory of somebody right who belongs to that particular country. And that is where science teaches you what humanity is all about. It's way above all countries. Science has no boundaries. Science has no religion. Science does not care which country you belong to. And that is what Kuvempu was talking about. Yenadaru agu, modalu manavanagu. That's the first thing. You have to first become a human being. Amele vishwa manavanagu. You are a global citizen. Don't associate yourself to one country, one religion, one land, one state, and fight over it. It's meaningless. See the beauty of mathematics there? You should. Take a wild guess what this is. Sun from Pluto. Very good guess. Fantastic. Good thinking. Good thinking. Galaxies. Okay, there are dots. You could mistake them for galaxies. Yeah. Then Venus from Earth. Just miss the orientation. You can see your photograph there. Yes. You're one of the stars. So we're all made out of stardust. So one of us were there 10 billion years ago in the center of some star, definitely. Don't ask me. I will not tell you. Tell me what you think it is. Either say it is Jupiter. It's okay. It's okay to be wrong. It's okay to be right. Doesn't matter. Simple terms. What you're seeing is the Earth and the Moon from Mercury. You see those two dots there? That's the Earth and the Moon taken from one of the satellites called Messenger that went to Mercury very recently. So I think one of the guys was like you, sitting there monitoring how Messenger is going. Sumne ange, what will happen if you look at it back? He changed the coordinates of the camera and then the Messenger turned towards the Earth and took a photograph. It was not intended. It was not part of the scientific plan, but someone crazy did that. So we have this. It will tell you one thing. From Mercury, even if there is life on Mercury, they would not know that you are existing. This is all they will see. If they are seeing this, tell me how they will figure out that Burj Khalifa is the tallest building in India, in the world. It's not even seen there. How do you think they even know there are 7 continents that we are mugging up in the examination halls? There are 7 oceans. One is the deepest part. Mount Everest is the tallest. It belongs to India or Nepal. We don't know. We are fighting about it every day. Where is the India-Pakistan border there? I don't see it. Forget about India-Pakistan border. Tell me where Bangalore is, which is very close and local to me, right? Doesn't exist. When you leave the Earth, you need to understand that. You are going to leave all your identity. To the universe, you don't exist. And it doesn't matter what you do. Please understand, in the calculation of the universe, you are not a major term. You are somewhere in the 300th or 400th order of magnitude, speck, which really doesn't matter in first order approximations. Did that sentence make sense to most of you? Do you know what a first order approximation is? Please go ahead and read all these things because that's the language of mathematics that we talk when you come to MSc physics. We don't talk about those kind of, x plus iy is equal to something. No. We are only talking about first order approximations, second order approximations, spline functions, where do you fit these curves, bell curves, which part of the bell curve are you fitting, what's the weight that I'm going to add. The language of mathematics changes once you finish your MSc. Everything that you have learned is only foundations. What you use is dependent on that, but not exactly what you have learned in your textbooks, not the notes that you have made. When it comes to research, when I'm trying to, very good, understand something in the world, all right, I don't need your notes. I need to know what you have noted down here correctly. This is the atmosphere of Mars. Doesn't look colorful. Sunrise and sunset on Mars is not going to be as beautiful as it is on Earth. Simple reason being density of the atmosphere. It does not have a thick atmosphere like ours, therefore there's not much of refraction. Because there's not much of refraction, the sunrise and sunset on Mars looks like that. It's the actual color image that they've tried to take. All color, RGB, CMYK, whatever you want, they've put it there. It just looks black and white. Because there's nothing to scatter the light, there's nothing to trap that wavelengths that are so beautiful for us. How many of you wake up early in the morning just to see the sunrise? Very good. Those of you just to see the sunrise, it's very important. Whenever, see, at my age, you're going to get very busy. Trust me on this, this is the only time when people care about what you're doing. Okay? Once you leave your college life and go into professional life, they will only care how much money you can bring onto the table. They don't care whether you look at the sunrise, you enjoy the sunset and things like that. But when you get older, they will say, you should have done it. So I'm telling you right away, do it. And do it every day whenever you get a chance. If you're waking up early, you want to take a break from your studies, you want to take a break from your life, just go to the terrace of your house and look at the sunrise. Or the sunset, or the afternoon sun. Just look at it. You're here because of that. Not because of your parents. Your parents are just the means. But the purpose was there with the sun. You're around a planet at the right distance to actually sustain life, and you're alive. If the sun increases its temperature by 5%, we are done. All of us are done. All that climate change and everything that people are fighting about, they have left one factor there. They are only looking at what industries are doing, how many trees we are cutting, how many roads we are laying. What they're forgetting is sun is getting older. And as the star gets older and older and older, its surface temperature is going to increase for a while. Once its surface temperature increases by 5 degrees, that means the global temperature on the Earth is going to raise up by at least 3 degrees. That's good enough to vaporize all your ocean. And I don't know what all of us will do. But what I know for sure is, it's a million-year process. It's not something that will happen today, tomorrow. So I'm overconfident about my maths. If some of you come here and say that all our maths is wrong, then I will have to go back and redo the calculations. Okay, but otherwise we are fine. So basically, from Mars, this is what you would look like. You and I, today, if somebody is looking from Mars, that is all they can see us on. That's what distance does. But see, the best part is this. We've seen craters on Mars. And that has also given us ideas on how to determine speeds of the asteroids, speeds of comets, how they're traveling, what impact can they do. And if they've done that impact crater, then what was the density of this object which was actually impacting it? We don't really need to experience all of this standing there. That's the power of mathematics. And that is what the universe has given us as a tool. That look, I am thinking in terms of maths. This is how I'm going to be. You need to discover the math correctly and then do it. The only thing that I've always enjoyed in mathematics are the prime numbers. You know why? Any idea why I appreciate prime numbers a lot? They just care about themselves. Nothing else. Nobody else can determine who they are. Yeah? They're just themselves. And if two of them multiply and give a new number, imagine your factorization problems. You're done. Imagine if you're a factor of two large prime numbers, 6-digit prime numbers. You're over. And imagine if the universe is just a product of two large prime numbers. And all your role is just to determine that. Build the world's fastest supercomputer, it will still not be able to do it. That's the beauty of the prime numbers. And in any language, in any civilization, wherever it is, the definition of prime numbers would be the same. You may call an odd number an even number an odd number in any names, but the prime numbers, they have their own property and that property remains. That is why in mathematics, there are so many things that are so beautiful. You need to appreciate that. Maths is not about, oh, I have to finish this examination. Math is more about what can I dig deeper and understand more that others have not been able to understand. Imagine the movement from Newtonian physics to Einstein's gravity was purely mathematical. When he was thinking about, Newton never thought about the speed of light to be incorporated into his calculations of velocities. Einstein did that. He put it there into the equation and he discovered special relativity. And he said, all your Newton's laws just don't work here. That was a mathematical insight. Though he was physically looking at it, he could only prove it to people if he had derived that equation. Imagine all that work in just 3 letters, E equal to mc square. Of course, it's not the exact equation. E equal to mc square is only an approximation. That is why I said approximations, first order, second order approximations are very important for you to learn. In mathematics, please pay focus on that, on what an approximation is. That is why we always use that word, determine. Not everything is deterministic. You'll have to deduce a lot of things. Once you're able to do those things, only you will be able to detect stuff. For example, Pluto, Neptune. They figured out all these planets existed because of mathematical calculations. Okay, I'll tell you one more story. There are these things called astrometric binaries. I've not put it here, but anyway, it just stuck my mind. I'm going to share that with you. Among stars, there are binary stars. Okay, there are very few Vivekanandas in the star kingdom. I mean loners, people who are lonely, unmarried. Yeah? All stars generally have a girlfriend. They are all binaries. Some of them have multiple girlfriends also, which means they live in a 3-star system, 6-star systems. The Proxima Centauri that we talk about, right, is a group of 3 stars and 3 stars going around each other. Sun, for some reason, is alone. It's not a binary system. If there had been 10% little more mass than what Sun started off, Jupiter somehow could have become the second star and we would have been in a system which had 2 stars to go around. But I don't know if that system would have had life on Earth and things like that, because that's a new dynamic problem. And 3-body problems, usually in physics, we just avoid saying that, yeah, there is a 3-body problem, we don't want to solve it. Okay, because it's not simple to solve 3-body problems. All right, so that is where it is. But coming back to the point that I was talking about, there are astrometric binaries, binaries that can be detected as binaries only based on their change in position in the sky. You don't get to see the other companion. Okay, so imagine somebody who's walking on the road talking to himself. Right? In his mind, there is somebody here, he is talking and going, but for you, there's nobody there. That's exactly how stars appear in the sky when they're just wobbling without seeing the other companion. The best example for that is the brightest star in the night sky. Anybody? Which is the brightest star in the night sky? Venus na star anta helorge degree ne kodbedi. Huh? The brightest star in the night sky. Give it a shot. Obru anyway heladru Venus anta. That's a good thinking, because that's the problem with our textbooks. We write things wrong. And we expect children to remember the wrong things and write it correctly. Gottagatalva? That's the paradox of Indian education system. Anyway. Star that is the brightest in the night sky. You can actually see it tonight if you go out. No, pole star is 4th magnitude. It's not the brightest. Very good. Go back to your 8th, 9th, 10th standard textbook. Nimagella bardidivu, nave bardidivu textbook alli odi. Okay? The brightest star in the night sky, I'm not going to take the name now. I'm taking it as a grudge against you. Anyway, right? This particular star belongs to the constellation of Canis Major. Okay? It's called the Big Dog. And there is this star which is very, very bright. And there was this mathematician, Bernoulli. You heard of Bernoulli's theorem? Bernoulli was observing the star, and he figured out that every time the star crossed the meridian, the line that's right above your head is called the meridian, the Great Meridian. Whenever it was crossing the meridian, it was not crossing the meridian at the same position. Its location would drift over a period of 1 year when he measured it. And then he said this can be possible only if that star was in a binary system. This was the first time somebody, without seeing another star, had actually detected a binary system using calculation of the position, astrometry. That is why they are called astrometric binaries. Okay? And this was purely a mathematical thing to do. So the universe gave us the mathematics to understand itself. It allowed human beings to discover prime numbers, it allowed human beings to discover positions, discover angles, discover trigonometry as a concept, and then start exploring the universe the way it has created itself. Right? Another empirical formula, that's more about deducing there. So you can use this particular formula, Hg is equal to 9.909, 10 to the 5 by g, g is the acceleration due to gravity, to find out how high can a mountain be if it's made out of granite kind of rocks, not like sand, granite kind of rocks, like our Himalayas, like Everest. You can actually find how high Everest can ever grow on the surface of the earth. Right now, Everest is around 9 kilometers high, 8.8 or 8.7 kilometers high. It can only go up to 9.4 kilometers, not more than that. You increase the height, it will fall down on the sides because gravity does not allow it to go beyond that point. So something like this is on Mars. Okay, this is Mount Olympus on Mars, and this is 21 kilometers high. This is 3 times the height of Everest. But it doesn't look like this. It's 27 kilometers from the surface, but it's spread like that. The angle at the top is not peak like this, it's like this. So you don't realize that it is actually 27 kilometers. So there are things that are much bigger. We know about those things, and these are all empirical formulas. There are no direct derivations for all of these things. People have done some observation, they've figured out how to do it. So that's why they call roughly, this is the equation you can use. Okay? How much time do I have? Oh, okay. Still have some time. All right. How many of you hate chemistry here? Wonderful. How many of you are mathematicians who hate chemistry here? Maths guys who hate chemistry. Come on, raise your hand. Very good. Wonderful. You will not understand what I'm talking. Anyway, hating chemistry and spectroscopy are not two different things. Don't worry. So this is another way nature talks to us, the universe talks to us in terms of spectrum. Spectrum actually tells you what's the size of the atom. Surprised? Spectrum of an element actually tells you what's the size of the atom. All right? So that's the reason why chemistry became so dominant in the last part of the 19th century and the early part of the 20th century. People were going left, right, and center crazy determining spectra of every element. And somebody asked Einstein, why don't you just go and do a PhD? And Einstein very simply said, I'm not interested in the spectra of this element or that element. I want to know what the God is thinking. Imagine, that was the audacity of Einstein. He said, I want to know what he is thinking. That's the reason why he went behind the maths of it, because he was thinking in the language of mathematics. Nature is thinking in the terms of mathematics. If you understand the math of nature correctly, you will understand the entire creation comfortably. Your skill needs to be more mathematical. Okay? So the best way to understand the world around us, the matter around us, is by looking at the spectra that the matter is going to give you. Based on that, today we are able to go to Mars, collect a sample, and then say, what's the chemical composition of Mars? And all of this, people have never gone to Mars. You should know that in the first place. Many people think that Narendra Modi also went to Mars. He didn't, honestly. He just gave a lecture about that, he just announced it to nation that we've sent something to Mars. People assume that Mars jaake aa gaye Modi ji, that is how it is. So let's not do that. What we've done is we've put a rover on Mars, okay? And the Mars rover is collecting information all on its own. It's been designed sitting here on Earth. That's the power of mathematics. They're able to guide a robo on the surface of Mars, completely guiding itself. That's the power of artificial intelligence. That's the power of data analysis, big data. It's learning every time it's doing something. So the first inhabitants of Mars are the flyers and rovers of America. If they become self-aware, they will not allow human beings to go and land there. That's when you will have the Decepticons and all those things. If you're fond of Transformers, that's basically the beginning. And this is another just for the fun of numbers, okay? See, the time delay between London and USA is around 6 hours. So any translations, any delays will happen over 6 hours. But from Mars to Earth, within 14 minutes, we get all the communication. It also means if I am typing something for the computer on board the rover machine, it takes 14 minutes for that computer to receive the information and process. Within that 14 minutes, if anything happens, that robot is at the mercy of nature. Nothing in this world is instantaneous. Though it appears to be instantaneous between you and me, we still have a time delay which is defined by the velocity of light. What you are seeing me, if your eye could sense the speed of light and look at the difference in terms of nanoseconds, you would be seeing me move frame by frame. And this motion, which appears to be in real time for you, actually is not complete, is not real. So, you think I am here, but I am not. Now let's come to similarities that nature creates. Why does universe create things similar? Because it's easier that way. Because you take one mathematical equation, you apply it to every system. It's easy to govern it that way. So one of the simplest things universe uses is gravity. Everything in the universe is controlled by gravity. And gravity, you all know, it's simply gmm by r square. Same way, you look at the solar system, that's part of your solar system, and this is Saturn, and this is Saturn's system. Does it look similar? Does it look familiar? Saturn, the system of Saturn, the rings of Saturn, probably like the asteroid belt, some object sitting at the center, and then 70 or 80 moons of Saturn that are going around. Exactly like the solar system, where there's a star at the center, there are planets going around, and then there are planetoids and your meteors, all these asteroids going around. They are very, very similar. Universe seems to be copying and replicating its structure everywhere. Same way it happens with the galaxy. The galaxy also has a similar structure. There is a central core, everything goes around the galaxy. Probably the universe itself is like that. Something else at the long distance, it's all going around, and we still need to perceive it because we haven't gone out of the universe. If we can go out of the universe, maybe we understand something more different about the universe itself. But we also know that we cannot go out of the universe because the universe is creating itself. Okay, so that's the problem there. And somebody called Bode actually discovered that law. That's what I'm looking at. Someone sitting here will discover a law. The only way you will discover a law is if you put your mind to it. You have to collect the data, you have to analyze the data, and then come up with the understanding of what the data is telling you. If you look at the history, I'll tell you the story of Tycho Brahe and Johannes Kepler. Kepler came with the idea of planetary motions not based on his data. Kepler gave theory of planetary motion or the equations of planetary motion based on Tycho Brahe's data. Tycho Brahe was obsessed. He had an OCD for accuracy. He wanted to measure position of objects as accurately as possible, and he had built a reputation to such a way that if Tycho says it is there, it is there. And during the time, he had never shared his data with anybody. The last part of his life, when he fell sick and he was no longer able to get up off the bed and then go and do his work, his friends came to him and said, look, you've done so much of work, why don't you just share it with somebody? And that is when he invites Johannes Kepler to come and say, can you have a look at the data? And Kepler plots the data. All he does is he simply takes the data and plots it on the graph sheet. And he figures out that Mars is not fitting in the right orbit. Because at that time, Copernicus had told that everything is moving in circles around the center of the sun, around the sun being at the center. So Kepler used that idea and put circles there, but he saw that there were no circles. Planets were not going in circles. And he came up with this first law: planets move around stars in elliptical orbit. And that was because he trusted that Tycho Brahe had not made a mistake in measuring the position of the planet. And that is how laws have come up. And Kepler's laws could directly be derived from Newton's laws and vice versa. You could do that. Therefore, there was more consistency. In mathematics, that's exactly what you look at. You look at consistency. You should be able to derive other laws from the most fundamental of all the laws that you study. Otherwise, there's something wrong with the way you are interpreting data. Okay? So Bode came up with an empirical law saying that you can find the position of planets because there seems to be that most of their position lie on a straight line. As you plot the distance between the log of the period of rotation towards their position, distance from the main star. And he also came up with the idea that there must have been a planet between Mars and Jupiter. But it just didn't happen. The planet lost its life even before it could be formed. And then you have the asteroid belt. And remember, these are the people who never went to space. They did all of this from their backyard. They didn't have Google. They didn't have Instagram. They didn't have Facebook. But they left their face for everybody else to read it in their books. Remember that. It's very powerful there. This is just for fun. Just have a look at it. These are some of the moons of Saturn. Some of this look like coral reef. I'm sure you show this to people who are fanatics about Hinduism. They will say, this is the kind of rock they used during Ramayana to throw into this ocean, and then Rama could go to Lanka. Okay? Basically, that's exactly how the structure is. It's a structure of a pumice stone. What you need to understand is, people have these examples everywhere. But it doesn't mean they're connected to one another. It doesn't mean they're not connected either. You need to do scientific analysis to prove either way. So what we've done so far with all the maths that we know from the universe is we sent things on its own out of the solar system. As of today, we know that 40 years ago, whatever satellites like the Voyager 1 and the Pioneer 1 that we launched, when I say we, I'm talking about the Americans launched, has left the solar system today. We don't have control over them, but we are getting very minute data from them about how the environment is. But those data are all so feeble that we are not able to analyze them. But we know where it is. Okay? And this much we definitely know about different sizes of objects that we have. We measured, and most of them, if you see, they all seem to be spherical. Nature loves some kind of symmetry. Then we did something more. We were not happy with, things going around the sun around. Then we launched certain satellites that could actually measure the light from the star as accurately as possible. Then we found something more than that. Every time we were measuring the light of the star, there was a dip. And there was a dip in the starlight. The star was there, but we were seeing that the starlight was actually going down and up and down and up and down. There's a variation. Based on that, we were able to derive that there are different planets that are crossing the disk of the star thereby obstructing the light. So these are the method of eclipsing. This is how you study planets which are bigger like Jupiter. They can do this effect. Planets like Mercury and Earth, they cannot do this around a star. So by looking at how much light from the star is being eclipsed, we are able to figure out what is that planet size which is, blocking the star light. Using that data, we found that there are stellar systems, there are star systems which look very similar to our solar system. Planets very close to the sun, very close to that star. Because we know sun is an yellow star, we always look for stars that are yellow in color. Familiarity. And we also know that universe follows a pattern. There's a mathematical pattern to everything universe does. That's the beauty of that. That is why we are able to go and look for yellow stars with planetary system like our solar system. The moment you find all this, see, we found so many such stars going around. We didn't stop only at yellow, we also went to blue, we also went to red, we looked at everything. As human beings, we are curious. We want to go and explore as much as we can. And so we know there is a Kepler 20e, which is as big as Venus, something like that, and 20F is slightly bigger than the Earth. So this is for you to understand that we are searching for terrestrial intelligence, extraterrestrial intelligence. The reason why we believe in that is we believe nature has a mathematical formula for the evolution also. We still don't know what that formula is, but we know that there is a formula. There is a structure that universe is simply replicating. So there's a galaxy, there's a solar system, there's a planet, there's a life. It needs to do that. And if there are 100 billion galaxies, there should at least be 100 billion life forms. At least. That's the rough estimate that we're talking about. No plastic bottle water. Thank you. Right? So this is an example. As of 2013, we knew 1,234 stars with planetary system. That is what mathematicians do. When they're cranky, they just don't keep a good number. Not roughly 1,200 or 1,000 stars. They wanted to give that 1, 2, 3, 4. So 1,234 stars with planetary systems were detected within a span of 3 years. Today, if you want to do research in this field, you still have the scope. You need to understand big data analysis. You need to understand how to interpret the light curves and then be part of it. You don't need to do physics. If you're good at math, it's good enough. If you're doing physics, it's even better. So much to explore. Why so much to explore? Because there's so much life to find. So we used chemistry, spectroscopy, and figured out there is alcohol available in space. People who want to drink. Yeah? But that's in the purest form, so naturally that will be your last drink, right? And you cannot take glasses there, all right, because it's heavy. Anything heavier, the astronauts are always asked to leave it behind. No carrying luggage, you have to go light. People who are lighter only will go to space first. People who are heavier will be left on gravity, on the mercy of Earth. So please start working out, reduce your weight to below 75 degrees. I'm 76 now, I'm trying to reduce it to 75 kilos. So that it's easy for the space shuttles and others to carry you. Okay? So start working on that right now. If something goes wrong, they will only choose people who are fit to carry. People who are not healthy, they'll leave them behind. Okay? And then you will sit and curse that, look, they did not care about it. They took my tax money, but they didn't take me. They won't. You have to be healthy. You have to prove that it's worth taking you somewhere. Okay? That is why do good in math. If you're good at maths, they will not look at your health, they will take you. The best example is Stephen Hawking. Universe will hire you no matter what you are, because your up here is like valuable than anything below that. If this is empty, this has to be good. If this is good, this can be whatever it is, it doesn't matter. That's the mind-body duality. Okay? Understand that. So we looked at the Orion Nebula, for example, and then we found out what are the chemicals that are found there. So we are able to do that because, again, there is a signature. Every atom, every molecule has a spectral signature, which is purely mathematical for us to understand. All right. This is just fun for you, okay? So understand this. Okay, how many of you understand magnetic intensity? The strength of a magnetic field. Can anybody tell me what's the strength of the MRI machine that you generally have in the hospitals where you go through? Some of you might have gone through MRI machine. I can't. I've got a metallic rod in my leg, so I will probably be sticking to the magnet right through there. I can't do that. I can only go through a CT scan, which means a shot of X-rays. By end of that journey, I would probably be suffering from cancer. That's a different thing. That's a problem. You need to understand. Everything that looks colory, goody-goody is not always right. That's what Marie Curie thought. She was keeping pitch blende right in her pocket, walking around without realizing she is exposing herself to violent X-rays and then got into cancer, right? But that was their life. They were inspiring others. They're inspiring people like you and me. Who are we inspiring? Understand that. 10 to the 15 Gauss. Anyone can tell me what's that strength of the field? What can it do? And what you're seeing there is actually called a neutron star. And a specific name for the neutron star, it's called a magnetar. A neutron star that has the highest magnetic field strength that we have known in the universe. What do you think that magnetic field of that strength can do? And neutron stars are not bigger than 14 kilometers. They're dense, compact objects. If you put a neutron star on Earth, Earth will actually go inside out. That's the problem with a neutron star being closer to Earth. It can actually do that. But anybody take a wild guess what this magnetic field can do? It could influence light, definitely yes, because light is electromagnetic in nature and this magnetic field could interfere with light. It could produce a lot of redshifts, it can do that, yes. But there's enough gravity to do that also. There could be a gravitational redshift. This magnetic field, imagine this situation. I take this neutron star and put it on the moon. Okay, I'll put it on the moon. Earth has its magnetic field, so I'll put it on the moon. And moon is how far away? You should know this data. At least boys, that's how you impress girls. Come on. Huh? Otherwise, nerds, nobody's going to marry you. Come on. Yeah? Girls, anyway, they're very powerful. They don't need to remember anything. But still, if you know it, it's really better. What's the distance to the moon? When somebody says you look like a moon, it's not a compliment. I showed you how the moon looks like, right? Craters. Huh? When someone says you look like a moon, it means that they're actually telling you you don't look beautiful. The close-up of the moon is never good. Moon looks beautiful from a distance. But what's the distance of the moon? Rough estimate, tell me, 10 kilometers, 20 kilometers, 1,000 kilometers, where is it? 2 lakh plus kilometers, roughly, okay. Yeah, 250,000 miles, that is where it is. 250,000 miles, 0.25 million miles is the distance to the moon. So I'm going to put the magnetar on the moon, 250,000 miles away from you, and I'll hold up my credit card, right? I just hold it up like this. The magnetic field is so strong that it can rip this magnetic stick out of it. I cannot handle my credit card near a neutron star. So when you're traveling in space, your credit card is useless. So all the credits that you will need to carry will be in a different form, not in form of money or in the form of cards. That's the strength of a magnetic field. And these are all natural. Nature has created these things. You cannot create these kind of intensities on the Earth. The strongest we have is the Large Hadron Collider. Okay? And the MRI machines that you have is between 1.5 to 3 Tesla. Nowhere closer to what we are talking about. Okay? The next experiment we did was this, laser interferometry gravitational observation. So this is where they could actually, you can see the green lines coming in here. They are the disturbance in space, so tiny that they can change the laser's accuracy by a few nanometer. And that can be detected today. Using this, they are able to find out the disturbance in space and time created by two black holes spinning around each other. Not in our galaxy, not closer to our solar system, somewhere far away. They're doing it, and that is sending the ripples to the Earth. You and I will never feel it, but this equipment can actually detect it. That's the power of how much we understand about the universe. And this is currently in space. It's doing its work. And this is how they detect black holes and neutron stars. Not by putting up a telescope and seeing through it. It's an indirect method of detecting. So we have done some work with that. So today we have so many pulsars and neutron stars that we have detected in our galaxy. Okay? And also there seems to be some kind of a pattern in which it's arranged. People are discovering how these patterns come up in the galaxy itself. So you can see that. Does it make any sense to anybody? Do you see any pattern? Give me yes or no. How many of you think there is a pattern? How many of you think all these four images are different? Just raise your hand. How many of you think this is the image of the same object or image of four different objects? Shoot the answer. That's fine. Same image from different angles. Fantastic thinking. How did they change the angle? Different? Different time. That's a good idea. That's a good idea. Same object taken at different times. Very well. Wonderful. Take 1 hour time. That's the answer actually. What's 1 hour time? Frequency. This is taken at different frequencies. This is the same source taken with different frequencies. That means that's the infrared light, that's the X-ray, that's the visible light, that's the gamma radiation. Same object taken in different cameras gives you different information. Put them all together, you still have not understood everything about it. If you take every living organism, trust this, if you take every living organism, unicellular, if there are half cellular, even them, to all the creatures that are there on the earth, bacteria, virus, put all of them together. Put them all to sit and study the universe. They would have still understood 2 or 3% of the universe only. Because there's so much information, we don't have hard disks to process them. Okay, so this is one curve, just remember this. We call this as the light curve. How the light increases and decreases with time, that's all it means. Using the light curve and the shape it takes, today we are able to find out distance of galaxies. A light curve tells you how far an object is from you. Right? So if I look at this light, I know this and that light are same. They're same bulb, right? The same LED that they have used. But their intensities are different because they are far away. One is closer to me, one is far away from me. By knowing what's the drop in intensity, I can say how far that light is from me. I can do that. Yes or no? That's the reason why you know stars are far away from us. Because some of them are much brighter than the sun, but still they appear like a dot in the night sky. Same method. They use the same technique to actually figure out what's the distance of these galaxies. In the process of doing that, Hubble looked at a lot of these objects and he came up with this law. He figured out that as you go far and far and far from the Milky Way, look at the objects deeper and deeper and deeper in space, they seem to be moving faster and faster away. That was called the Hubble's law. And that law, V is equal to H, basically they have not used H naught, but it's okay, H naught D. H is called the Hubble's constant. The inverse of the Hubble's constant tells you the age of the universe in seconds. See the beauty of mathematics, how cleverly the universe has hidden the secret in a very simple empirical formula. It's not a differential equation. It's not the integral equation. It's not a Fourier series. It's not your Lorentz transformations that you're studying. It's a very simple empirical formula. V is proportional to R. The velocity of the galaxy is proportional to its distance from the Earth. You know how funny the universe is? It's kind of playing with you. It's giving you so many ideas about mathematics, so many different forms. And it's saying that, no, I don't operate with all that. You can learn that for the fun of math, but I am very simple. And the secret is this, 1 over H is just the age of the universe. What does it tell you? It tells you that the more accurate you can find H, what is H? Slope of the line. Where did you learn this? You learned it in 10th grade. How to get dy by dx, that was in 12th. But how to find a slope of line? y2 minus y1 by x2 minus x1. That's all you did, right? That is all you did. By doing it correctly, as accurately as possible, you can find the age of the universe as accurately as possible. Now you can question back, why am I doing MSc mathematics when everything is so simple? After my 10th standard, I should have been able to discover the whole universe on my own, which is true. Which is very, very true. You can actually discover a lot of things with basic mathematics that you have. But if you want to talk to people about it, you need to have a little higher order mathematics. Because people are complicated. Universe is not. Then some of the things for you to enjoy. These are the pictures of the ripples around a black hole. Okay? So we are trying to understand how this space-time ripples are coming up. What's the density of the object at the center? How can we make sense of all this? This is basically a quasi-stellar object, which means it's not like a star, it's not like a galaxy, it's somewhere in between. Right? More like a Kannada, adukku mele, something like that, in between. That is what we are talking about. So this is something that people are doing. And you see the number here. Can anybody tell me what that number is? 1635 plus 119 or 119. Take a wild guess what that is. Every time you read an article, these numbers will be there in them. It's bound to happen. What is that number? "50 years from now, people will forget your names. You will all be given your Aadhaar number. Trust me on that. If you're walking by, there are sensors everywhere. They'll sense everything. And they will give everything about you to the world, just like that. Today, what you're doing, where you're sitting, is all being recorded by Google. Because you have a smartphone with you in your pocket. How are they doing it? Same. This is the GPS for the stars. This is the GPS. This is called the coordinates of the star. The right ascension, declination, or the galactic coordinate systems. They are basically the coordinates of the star, where they are. You need to understand the positions because that's easy to detect them when you're looking for them. Okay? These things you cannot see with telescopes. So you need to go to space and do it. So we did that. We found something. I'll come back to this a little later. Okay? This is something I want you to appreciate. The one there is not a galaxy. Anybody what that is? Cyclone, it's a hurricane. That's a galaxy. What's the difference between them? What's the difference between them? One is cyclone, the hurricane, the other one is a galaxy. What's the difference between them? See, technologically, what I've done is I've just equated them in terms of size. I just stretched one image and put it up there. But in reality, this is just water. That's life. That's hydrogen, helium, everything that you can think of. Everything is there on that. In this, it's just water. We are scared of water when water starts spinning above your head. It's just water, nothing more. And the universe is, this galaxy is spinning continuously, but not as fast as the hurricane spins. But they all spin the same way. Nature seems to be left-handed. The DNA is a left-handed double helix, twisted like this, not like this. That's the catch. The galaxy you're seeing there is actually being spun. Of course, this image is inverse of it. Usually it's the other way around. It's actually the left-hand spin. The Earth is rotating west to east, which is a left-hand spin, not a right-hand spin. If you do a right-hand spin, it should go clockwise. The Earth is going anti-clockwise. The solar system is going anti-clockwise. But the best part is that, right? What is anti-clockwise from here looks clockwise from here. You just change the direction in which you're seeing it, everything changes. But most of the objects we see in the sky all have anti-clockwise rotation. So I was in a college and I told them God is left-handed. They got offended because they thought you cannot see God. Right? And I was telling them that that's how you see it. What's invisible to a lot of people is actually visible if you open your eyes. Next. Every dot here is a galaxy. And the best part of that is the universe is very isotropic. Uniform distribution. Wherever you are in the galaxy, wherever you are in the universe, it just appears the same. It's called the cosmological principle. You can always understand that when it comes to the physics part of it. But the best part of it is it looks the same no matter where you look at it from. Do you see anything in mathematics there that it looks the same no matter where you look at it from? Which part of maths tells you that? There's a field of mathematics which talks about self-similar systems. Anybody? Yeah? And what do you call them? Self-similar systems. Fractals. Universe seems to be like a fractal. That is why I feel personally that universe loves mathematics and it loves mathematicians. That's why it kills them early. If you're very good at maths, you will not live beyond 45 years. Okay? You're extremely good at maths is when you will enjoy. Like Paul Erdosh and all those guys. They're still alive, they're doing a good job. But the thing is, what they do, we don't understand. Some of the top minds in mathematics have never crossed 45 years of existence. Okay? Because they seem to be burning their brain energy so fast that they're finishing up their life very fast. So the choice is yours. Do great math and die soon, or just do ordinary maths and live longer. All right, so I'll leave you with this. 13.7 billion years since the universe. We've come a long way. We've kind of had a lot of interactions. We've understood a lot about the universe. We are somewhere here today, and we've looked back in time. We don't understand a lot of things. Okay? For example, okay. We don't understand a lot of things, okay? And we are yet to discover new methods of understanding the universe. We still need to find the unification theory, all right? So there is so much to do. And each one of you can actually contribute towards that. That's what I started off with, telling you that our purpose here is to get that information from our seniors, from the people who have done research work, process it, convert that into something that is better than what they left behind, and leave it for the next generation to start processing it further. The more and more you understand, the better it is, so that you can propagate towards other parts of the galaxy. Within our lifetime, we will not travel anywhere else, but we are setting the foundation for the next generations to go. So if somebody comes to you and says, the whole country is suffering with poverty and all that, why do we need space travel and all those things, whack them once on their face, tell them to eat less so that people can get food. That's the only way you can avoid poverty. You have to eat less so that the other guy can get something to eat, not stopping science. By stopping science, you're only stopping progression of knowledge. Once you stop progression of knowledge, you will have nothing else to live with, so you will fight about everything, literally. When you have something to think about, your brain does not wander here and there. If you've got what I'm saying, good. Yeah, so this is something I wanted to show you. Look at this blue dot is the farthest you can ever see. You can say proudly, I have seen the farthest object in the galaxy, in the universe. Okay, that is around 10 billion years old. That means it was 3.7 billion years when it was there, and we are able to see it today. Okay, that simple dot doesn't make much sense to you, but it's actually called a quasar, quasi-stellar radio source. People are still working on what they are, but yeah, that's the farthest in the galaxy that we have seen, the farthest in the universe, the deepest part of the universe that we have seen. So this is just now being launched. All right, maybe a year later or 2 years later when we meet again, we will talk about this, because data is yet to come. We are yet to see the universe through this telescope. It's going to be fun. I'm really excited about what it can show us and how much more clarity it's going to give us about the universe and how simple it's going to make the understanding of the universe itself. All right? So thank you all for your patience. Any questions, I'll take now. Oh yes, quite a time.
Any questions?
Anything? Oh, illa. Sumna nanenu akala. I'm not universe to simply put something there and confuse. Nagar is my company. I started it with a couple of my friends, and Nagarali, we help people understand math and English basically, and we also help them understand how to learn, how to look at learning itself as a process, okay? So that children at a very early age will be able to understand what's the process of learning and why they should learn something. Okay, so it's an activity-based learning center. We have products that we give to students. They can use it, practice. We start as fundamental as 2.5 years old, and we do it all the way up to people who are doing research. So we cater to everyone in that spectrum. So Nagar is city of numbers. That's what it means. That's the reason why I'm talking to you today about maths, right? Okay.
Any other questions?
Anything that's in your mind. Yes? Oh. The Earth's orbit is not tilted. Earth's orbit is just like this. The Earth is tilted. The axis of rotation is tilted. So it actually makes it easier. Plane launch ಮಾಡಬೇಕಂದ್ರೆ we are closer by 23.5 degrees. ಇಲ್ಲದಿದ್ರೆ ಹಿಂಗಿರ್ತಾ ಇತ್ತು, ಇಲ್ಲಿಂದ launch ಮಾಡೋದು ಕಷ್ಟ ಆಗಿರೋದು. But most of the launches happen from the equator region, not from the polar region. Most of the launching pads are all closer to the equator because the Earth's rotational velocity gives you an assist to reduce the energy to launch a rocket. That is why countries like India, right, have that advantage because we are closer to the equator. And we can control both sides, southern and the northern hemisphere. Okay? So countries which are in the north, like the European countries, they will need to depend on countries like India for launching their satellites. And that is how countries collaborate. So when it comes to axis of rotation, basically you have the Earth. Okay, this is the plane of rotation. Let's say this is the plane of rotation. Earth is going on the plane. It's actually tilted by 23.5 degrees. It's the axis of rotation that is there, not the plane. The plane is not tilted. The plane is just there. It's the same plane where you have the Venus, you have Earth, you have Mars and everything, except Mercury. Mercury is not in the same plane. It keeps oscillating that plane. That is because of the closeness to the sun and the gravitational field there. But Venus, Earth, Mars, they're all in the same plane. That's the reason why at some time you can always see them in the same alignment in sky. They'll all be in the same line. The moon is there in the same line. You can see all the planets because they're in the same plane. But the tilt in the axis, if this is the plane, this is the tilt. The axis of rotation is tilted by 23.5 degrees. They have calculated that and they know what is the velocity with which each one of them is moving. So using that, depending on where the launch pad is, they can always work the mathematics and then they can launch the satellite. So that's pretty basic Newton's laws. They don't really need to worry too much about that.
While you were talking about near and far phases of the moon, right? I just heard in the audience that it's because the moon has no rotation. Okay. So I remember last time when you were here in the same auditorium, you gave a demonstration, right?
Sure.
If you could do that again, it'll clear a concept.
Okay. So let's try this.
Called an volunteer last
I'll
time.
need one person from the audience. If you can come up. Anybody, just come up. I'm a non-vegetarian, but yeah, I don't eat people. You can come. Come. Very good. So let's assume that this is the Earth. That's the moon. You can stand there. All right? And the Earth is rotating on its own axis. So for time being, we'll keep the Earth static. The moon is going around the Earth. Now the moon is also rotating on its own axis. But what it does is, it always rotates on its own axis at the same speed at which it is moving around the Earth. See? For the Earth, you're always seeing the same face, but I have actually completed one rotation on my axis, which I have done this. If I fix the plane, you can see the moon rotating like this. If you just fix the moon. But what is happening is moon is also moving and rotating. So every time it's moving and rotating, it's doing this. So it comes here, then it comes here. So if you actually see the portion, I'm making a rotation and I'm also revolving around the Earth. So at any given time, people on the Earth will only get to see one phase of the moon. So it is rotating, it's not static. If it was static, it would have been like this. You would have seen different phases. See that? Illinda idu kandirodu ivaga, aamele hinde kandirodu. That is not what you see. You will always see the same phase of the moon. When I'm here, when the light is behind me, you don't see the face. That's called the new moon or the no moon basically. And when I'm here, the entire light is on the face, you get to see the full moon or the Paurnima. That's better to use it that way because now I don't want to use the word full moon. It's not full, it's only half. Right? And because the Earth is also spinning and moving, they never complete the circle. It's actually a helical structure that they're doing. And see, the best part is this. The Earth is going around the sun. I am going around the moon. The sun is going around the galaxy. None of them are completing one rotation. The year never happens. You can go. Think about it. Neeven happy birthday antira, it's wrong. Birthday is celebrated when the Earth makes one complete rotation. It's never doing it. It's doing this. It's not completing the rotation at all. It's a helical structure. It's going on and on and on. So your birthday does not make sense mathematically. You know why most of us don't attend birthday parties? Because of this. Ella, happy birthday. There's no day. You have to celebrate. You have to calculate exactly what is happening. This is also the reason why time travel is not easy. Because when you're traveling in time, you should also travel in space. But nothing in space is fixed for you to travel back to the same location. If you travel back in time, the Earth is already moved out of that location. And you have to travel back in space and time, which means you have to reverse everything. Not going to happen. So time travel is not going to be a reality ever for human beings. You can dilate time, you can slow down the way time is running for you, but you cannot travel back in time. Good. So go home, think about it. I've given you some of the doubts, clarify them, and enjoy life. It's very important. You just have one life.
Good afternoon to one and all. I think today's lecture, it is not a lecture, it is an interaction session. I hope you have many questions now. You should answer, you have to find out the answer for that. Anybody remember the questions, today's questions? Huh? I think all are in present mind. Is it correct? ಎಲ್ಲ ಪ್ರೆಸೆಂಟ್ ಮೈಂಡಲ್ಲಿ ಲೆಕ್ಚರ್ ಕೇಳಿದ್ದೀನಿ ಅಂದ್ಕೊಳ್ತೀನಿ. ಸೊ ಇವತ್ತು ಕ್ವಶನ್ ಸರ್ ಒಂದಷ್ಟು ಕೇಳಿದರು, ಜ್ಞಾಪಕ ಇದೆ ಎಲ್ಲರಿಗೂ? ಸೊ ಯಾವಾಗಲೂ ಒಂದು ಲೆಕ್ಚರ್ ಕೇಳಬೇಕು ಅಂದಾಗ ಒಂದು ನೋಟ್ಬುಕ್ಕು ಪೆನ್ನು ಇಟ್ಕೊಂಡ್ಬಿಡ್ಬೇಕು. ಸೊ ನೀವು ನೋಟ್ ಮಾಡ್ಕೊಳ್ತಾ ಇದ್ದರೆ ನಿಮ್ಗೆ ನೆಕ್ಸ್ಟ್ ಅದು ಏನು ಮಾಡಬೇಕು ಅನ್ನೋದು ಗೊತ್ತಾಗುತ್ತೆ. ಸೊ ದಟ್ ಈಸ್ ಮೈ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್. ಸೊ ಐ ವುಡ್ ಲೈಕ್ ಟು ಥ್ಯಾಂಕ್ Sriraghavan SM, co-founder and president academics, Nagar, for wonderful and informative lecture towards universe and its love for mathematics. So now we got the information regarding how mathematics is related to astronomy. Is it correct? So, sir, it is a very informative lecture, sir. Thank you very much. So today we have one more person. He is very interesting. ನಾನು ತುಂಬ ದಿವಸದಿಂದ ನೋಡ್ತಾ ಇದ್ದೀನಿ. ವೆರಿ ಏಜಲ್ಲಿ ಮಾತ್ರ ದೊಡ್ಡವರು ಅಂತ ನಾವು ಹೇಳ್ಬೋದು. ಅದರ್ ದ್ಯಾನ್ ದಟ್, he is a very inspiring and motivational person. Today he is with us. That is Professor K.S. Nataraj, Director of our BVJ Jagadeesh Science Center. Sir, thank you for your presence. So I would like to thank Professor Mamata, Vice Principal of Pre-University College, Professor Chalwappa sir, HOD of Electronics Department, Mr. Asif, and volunteers, that is Ajit, Venkatesh, and one more guy, Charan and Uday. And also I would like to thank all the students and other participants and our department colleagues, Saumya, Sandhya, and Varsha madam. Thank you one and all once again.